In this lecture, we are going to cover the free body diagram. Free body diagram, in short, we call it as a FBD. In short, we call it as a FBD, that is free body diagram. Okay. Now, what is the free body diagram? If certain object is there, and that object, suppose that we are just taking an example, that object is resting over another object. That object is resting over another object. Then the amount of force exerted by this body, suppose that this body is having 50 Newton of weight. 50 Newton of weight. And this weight is contained by this body. Right? What is the definition of mass? Mass is the matter contained in a body. And what is the definition of weight? Weight is equal to product of mass and W is equal to ma. Mass into acceleration. And its unit is Newton. Its unit is Newton. And basically, it is directed in downward direction. Weight is directed normally in downward direction. Usually it is directed downward direction. Okay. So weight is equal to the product of mass and acceleration. And weight is also a type of force. Weight is also a type of force. Weight is also a type of force. That force is directed in a downward direction. That force is directed in a downward direction. Okay. Now, according to the Newton's third law of motion, to every action there is equal and opposite reaction. So therefore, an equal and opposite amount of the force will be exerted by the table on that body. By the table on that body. Okay. Body is exerting 50 Newton force on equal amount of force, that is 50 Newton in upward direction, and that force will be called as the normal reaction. Normal reaction. Okay. In short form, we may call it as a capital N or capital R or NR, that is the normal reaction. Usually R is the notation used or N is the notation used. To action, there is a reaction. So many times R is also used. R notation is used for the reaction. Okay. So what is the free body diagram? Free body diagram means when we enclose this body or when we isolate this body from its surrounding. Now we have isolated this body from its surrounding. The number of forces acting on that body is shown. That diagram is called as the free body diagram. That diagram we call it as a free body diagram, in which a body is isolated from its surrounding, and whatever the forces acting on that body is shown diagrammatically, and that diagram we call it as a free body diagram. So this is the definition. Now in simple language, whatever the forces acting on this body, first force is its own weight that is acting in downward direction, that we have to show. Okay, every force we have to show. Okay, this weight also we have to show here as it is acting in downward direction. As it is acting in downward direction. Now this is a complete free body diagram in which two things are shown. One is the weight and second one is the vertical reaction. This is the additional thing. This is the additional formula that I have written here. Weight is equal to mass and acceleration. But this whole diagram, we call it as a free body diagram. Okay. Now, free body diagram, various free body diagram can be drawn according to the situation and according to the forces acting on the body. Okay. Now, the n number of examples can be here shown in case of the free body diagram, and that examples we will see that in different conditions what are the different free body diagrams that can be drawn. Okay, but for one particular object there will be only one free body diagram. Okay, there cannot be a 2 or 3 types of free body diagram. For one particular object there will be only one free body diagram, but we will see the different conditions, different examples of the different bodies. Okay. So here various stable objects are shown, and for every stable object the different FBDs are drawn here. Okay, now one by one we will explain how the FBDs are drawn here. Okay, let us consider this first object in which a 15 kilonewton of box is resting over the inclined surface, and the surface is inclined by an angle theta. By an angle theta. Now, this 15 kilonewton force is acting in a downward direction. This 15 kilonewton force is acting in downward direction, and the reaction R here in this first diagram, you can see this. The reaction R is always perpendicular to the surface in contact. So always you try to remember this thing, that reaction is always perpendicular to the surface in contact. Okay. Now that reaction can be splitted into X and Y direction, that is Rx and Ry. That is the another thing that comes under the resolution of forces that we have already covered, that any force can be resolved into two components, X and Y. So in the same manner, resultant can also be splitted into two components, X and Y. Okay. Now, after that, this one is the free body diagram for this object. For this object. Okay. Forces are shown as well as the reaction is also shown. Reaction is also force. So therefore, it must be shown in the free body diagram, that is FBD. Okay. Now, what are the uses of FBD? Why we draw the FBD? FBD is the first step in solving the numerical of engineering mechanics. Okay. While you try to solve any numerical, you have to explain what are the forces acting on the body, and that forces can be diagrammatically explained by isolating that body from its surrounding. Okay, now this body is isolated from its surrounding, and only the forces acting on this body are shown. R is the reaction force, and 15 kilonewton is the its own self weight. Okay, this is the thing. Now if friction is there, then we can also show the friction. If friction is there, if friction is not there, you don't need to show it. If friction is there, you can show the friction like this, because body is tend to move the downward. So therefore friction will be always opposite in the direction of the motion of the body. you always remember this thing, that friction is such a thing that it will be always acting in opposite direction to the motion. Okay, suppose that your body is moving downward, it tends to move downward. This is the motion, this is the direction of motion. Then your friction will always be in a opposite direction to the motion, right? So this is the property of the friction, that it always go in opposite direction. Okay, now after that, let's see the next body. One circular object is resting and one rectangular object is resting adjacent to it. Circular object is having 20 Newton of self weight and rectangular object is having the 30 Newton of self weight. Okay, now whenever an object is resting over a flat surface will also exert an equal and opposite reaction on that object. Okay, so there are two FBDs for the two objects, because this object are two different objects. So for object number one, that is the for circular object, the FBD is different, and for rectangular object, the FBD is different. So first of all, we will consider the circular object. Now the self weight 20 Newton is given, which is directed in downward direction. Then reaction R, which is directed in upward direction, and RB is nothing but the reaction caused by this adjacent object. Adjacent object is pushing this body in left direction. So therefore, this reaction is directed towards left direction. Okay. Now let's come down to the body B, which is rectangular and which is having the 30 Newton of self weight. So 30 Newton of self weight is directed downward. Reaction R is directed in upward direction, which is from downward to upward. This is reaction R. And RB is directed from left to right, which is because of the circular object is adjacent to the rectangular object. That circular object will exert some amount of force on the your rectangular object. So that's why it is shown here. Okay, so these are the two bodies. Okay, now after that, let's move towards the last FBD, in which the two objects are resting one over another. First object having the weight of 10 Newton and second object is having a weight of 50 Newton. Okay, so the two objects are there and 10 Newton force is resting over 50 Newton. The 50 Newton is resting over the okay. Now, if we consider the object, so therefore, these two bodies we have considered. In first case, 50 plus 10, that is the 60 Newton, while considering the first object, because second object is resting over this first object. So that's why we have to consider that force also in case of the lower object, that is 50 Newton. Okay. And reaction R is acting in upward direction. Reaction R is acting in upward direction. Okay. Now let's consider only 10 Newton. Let's consider only 10 Newton object. Okay. Now for that 10 Newton object, there is another force which is RB, that is resulted by the 50 Newton force. Now for 10 Newton object, 50 Newton object is just a table for it, just a flat surface for it. Okay. So therefore, according to the Newton's third law, to every action there is equal and opposite reaction. So 10 Newton force, the action is downward, and therefore 10 Newton, that is the RB, is acting upward direction for body number 2, for the 10 Newton body. Okay. And if we consider the combined FBD, then 60 Newton is the addition of 50 plus 10, that is 60 Newton acting downward, and reaction R is acting in upward direction. Okay. So in this manner, we have explained all these three FBDs, that is the three free body diagrams. Okay. Now we will see another type of free body diagrams, that is for the pulleys and the cylinder or the circular object, means pulleys and the, what you can say, your roller. Roller is nothing but a circular object. Okay. So now let's move towards the next FBDs. Now there are different types of supports. There are different types of supports. Fixed support are there, hinge support are there, and roller supports are there. Okay. Now what is the reaction? The reaction is the action to the action. Reaction is action for the action. That is the reaction. Okay. Now, what is the property of hinge? Hinge can rotate in one direction. Hinge can rotate in one direction. One direction, two direction also. Okay. That is a hinge support. Okay. So whenever a hinge support is there, you remember that there will be two reactions. Okay. You can see here two reactions are given. One is horizontal, one is vertical. Okay. In case of the hinge. Okay. Now we are drawing the FBD for this roller. So that's why this circular object is, we have taken here in downward. We have drawn this separately because we have to isolate this body from its surrounding. We have to consider this body as a separate body from its surrounding. So therefore we are drawing the FBD for the roller. So that's why we have taken this roller separate. Okay, here we have drawn this roller at the downside, and we have to show the forces of acting on that roller only. Forces acting on that roller only. So that's why we have shown horizontal and vertical force as the hinge is there, and this beam, horizontal beam AB, is connected one end to the hinge and one end to the roller. Now this roller can move in horizontal direction and hinge can move in any direction. So that's why we have to show the two forces of reaction, for which this hinge is connected at the center for this circle. Okay. And roller will have the horizontal reaction. Or what we can say, the roller will not have any reaction. Roller will not give any reaction. Roller will give only vertical reaction. Why? Because it is free to move horizontal. So that's why it will not resist. And if some body resists, then only it will produce the reaction. Because some action will be there. When the resistance will be there, some action is there. And action to action is a reaction. So it will create a reaction. Okay, but here, because of only self weight, roller will exert the vertical reaction. Okay, but we are considering only the circular body, and that's why only the forces acting on the circular body we have to consider. And the circular body is connected to the horizontal beam, which is AB, and it is connected at its center only. And at the center, the pin joint is there. So that's why we have to show the horizontal and vertical reaction at the center of the circle. After that, there is a tension in the cable. Now, cable is connected at the end C at the top, and 100 Newton is connected at the downside. So therefore, 100 Newton force will be shown in the thread in downward and upward direction, because in both directions the 100 Newton force is there. Okay. Now, after that, we'll consider one more FBD for the object, which is at the center now, center of the diagram. Okay. The object is having the 500 kilonewton of weight, and that 500 kilonewton weight we have to show acting in downward direction. Now the next one is the 200 kilonewton object is connected by the rope, thread or string, rope, thread or string. So that we have to show acting in horizontal direction. This weight is pulling this object. We have taken this object isolated. Okay. Now to the action, there will be reaction. So 500 kilonewton weight is acting downward. So this flat surface shown here will also exert the reaction in upward direction. Now at the angle of 30 degree, the 100 kilonewton of weight object is directed downward. And that reaction we have to, that tension in the string we have to also show. The magnitude is 100 kilonewton. The magnitude is 100 kilonewton. Now, the third diagram will be there. And the third diagram is again a circular roller resting over the vertical object. That is the third diagram. And in third diagram, it is connected with a cord. It is connected with a cord AB, and it is resting at the point C at the vertical wall. Okay. So here also, the tension in the string will be the T, and that tension will be TAB. That tension will be T of AB. Okay. Tension in the cord AB, and that tension you can split in vertical and horizontal direction. That is TABX and TABY. That you can do. Okay. While solving the numerical, you have to split the forces. Okay. But in FBD, you can show only one force, that is the inclined force. Now, after that, horizontal reaction is there, that is the RC. RC will be the horizontal reaction which is exerted by the vertical wall on the object. Because whenever you are drawing the FBD, you have to consider only about the object. So on that object, the wall is also exerting the force. So therefore, you have to consider the RC, that is reaction exerted at the point C by the wall on the circular object. By the wall on the object. Remember this thing. Reaction is exerted by the wall, by the wall on the object, that is the circular object. By the wall. Now, in this way, you can observe these FBDs. There are totals. We are having the various FBDs now. We are having 3 plus 3, that is 6 FBDs in these 2 slides. Okay. for the study purpose. We are studying these FBDs. Okay. So you can consider these various FBDs for your understanding purpose. For your understanding purpose. Okay. Now after that, by observation only, you can study these FBDs. How to study the FBD? You have to observe the FBDs. You can study this simply. Okay. You have to observe the FBD, how the FBD is drawn. Now here there are two FBDs, one for the roller and one for this 100 Newton object. Okay, there are two FBDs. For the central object, you are having only one FBD for the circular object. Here you can see. Okay, two forces are there. One is 200 kilonewton and one is 100 kilonewton, which are acting in the cord. Next force, third, is the 500 kilonewton, which is acting downward, and reaction, that is acting in upward direction. So total 4 forces are there here. Total 4 forces are there. In last diagram, how many forces are there? 3 forces are there. One is the TAB, that is tension in cord. Next one is the 1000 Newton, which is the self weight acting in downward direction. And next one, third force, is the RC, which is exerted by the wall on the object, that is RC. 3 forces are there. Okay. So in this manner, you have to observe the FBD, and by observing the FBD, you can study this. Okay, just your observation should be there. Okay, now here also you can observe this thing. First FBD, 15 kilonewton object is there, which is resting over the inclined surface. So therefore, this 15 kilonewton weight will be acting downward, and reaction will be acting perpendicular to the surface. Remember this thing. And your reaction will always be perpendicular to this inclined surface. You can observe this thing. Now in next FBD also, for the 20 Newton and 30 Newton object, one is circular, one is rectangular. For 20 Newton object, 20 Newton force is acting downward and reaction is acting upward. And here the reaction exerted by 30 Newton for object, rectangular object, is acting in left direction. This 30 Newton object is pushing this object in left direction. So therefore, we have shown the RB here in left direction. Okay. Now consider the 30 Newton rectangular object. 30 Newton acting downward, reaction is acting upward. You can show this reaction which is acting upward. Okay. And RB, you can show acting in right direction. RB is the force exerted by circular object, which is acting in right direction. This RB will act in right direction. Okay. Now again consider the last third FBD, 10 Newton object and 50 Newton object. 10 Newton object is resting over 50 Newton object. So therefore, while drawing the 50 Newton object FBD, you have to draw the 50 Newton object and show the forces acting on 50 Newton object. One force is its self weight and another force is 10 Newton force, which is also acting in downward direction, right? So we have shown these two forces acting in downward direction, 50 plus 10, that is 60, and reaction R, which is acting in upward direction, right? Now next is the 10 Newton object. For 10 Newton object, 10 Newton force is acting downward and reaction RB exerted by the 50 Newton object, which is acting in upward direction. Only two forces can be shown here. Now next one is the combined FBD, last one, combined FBD of two objects, in which 50 plus 10, 60 Newton acting downward and reaction R acting in upward direction. Reaction R can be shown here acting in upward direction. Okay, so the simple 3 FBDs are there. By observation only, you are able to understand this. Okay, and when you have to draw the FBD while solving any numerical for the engineering mechanics, you have to draw the FBDs in the solution, or you have to draw some diagrams. Okay, If FBD is not there, you have to draw certain diagram. You have to show the diagrammatic representation. Okay. FBD is nothing but a diagrammatic representation of the all forces acting on the object when we isolate the object from its surrounding. This is the definition of FBD. Okay. Now after that, we will just see the equilibrium and finding the support reaction. Equilibrium and finding the support reaction. Now here, you just observe one beam is there, and that beam is beam AB, on which 4 kilonewton force is acting at the 6 meter distance from the point A. 8 kilonewton is an inclined force having 30-degree angle from the 3 meter distance from point A. Point A is having the fixed support, while as point B is having the roller support. You can see the roller here. Rollers are placed. Okay. Now, because of this roller, this point B can move in horizontal direction, and that moment will create the horizontal reaction force. That moment will create the horizontal reaction force. That will be RAX. That will be RAX. It has been shown here. This RAX. We have written this thing here, RAX. Okay. And we can also write this as RAH. H means horizontal. That is reaction acting at point A in horizontal direction. And RAV, that is reaction acting at the point A in vertical direction. So because this end A is fixed end and end B is roller support, so that's why one horizontal and one vertical reaction will be there. You remember only this thing. After that, split the force 8 kilonewton into the 8 cos 30 and 8 sin 30. You can split this force 8 kilonewton into 8 cos 30 and 8 sin 30. Okay. After that, no need to split the 4 kilonewton force, because 4 kilonewton is already acting in vertically downward direction. Okay. And next one is the RB. RB is acting in upward direction. That is the force exerted by the roller. And this roller is free to move horizontally. So that's why there will not be any resistance. And as the resistance is not there, there will not be any horizontal force, RBH or RBX. There will not be such force because the rollers are free to move. So they will not resist the movement. So that's why there will not be any reaction. Only the vertical reaction is there because of the self weight. As some forces are acting downward, so it will create a vertical reaction, that is RB. Okay. Now after that, we just move towards the equations. Okay. So consider the first equation, which is obtained by the conditions of the equilibrium. And what are the conditions of equilibrium? Already we have seen, that is Fx equal to 0, Fy equal to 0, and moment at any point is equal to 0. So these are the 3 conditions of equilibrium that we have seen in our previous lecture. 3 conditions of equilibrium. If a body satisfies these 3 conditions, then only we may call that body is in equilibrium condition. If it satisfies these 3 conditions, and that's why we are now moving towards the first condition, that is summation of Fx is equal to 0. Second condition is summation of Fy is equal to 0. And third condition, that is the moment at any point is equal to 0. So if these 3 conditions are satisfied, then we can call this body is in equilibrium condition, is in equilibrium condition. Okay, now it will satisfy the condition. Why it will satisfy the condition? Because this body is not moving. We can observe that this body is in stable condition. That's why it will not move. It is in stable condition. Okay, and you can solve this numerical. You can get the values of Rax, Ray, Rah, Ra, V, and various support reaction, that is Rb also. You can find the unknown values, right? And you can find the resultant of this Rah and Rav. You can see this resultant here. You can solve this numerical in a very simple manner. Okay, by using the regular procedure, you can solve this numerical and get the value of Ra and Rb. You will get the value of Ra and Rb here by solving this numerical. Take a screen.